Hello, everyone, and welcome. My name's Colin Mars, and I'm the editor of Construction News. It's great to have you all with us for today's session, Powering the Future, UK Data Centre Development, held in partnership with H&V News and RAC Magazine. The data centre market now is one of the most dynamic in construction. As demand for digital infrastructure accelerates, the sector faces big questions around land, power, planning, skills, investment, and delivery models. Today, we'll be exploring those challenges and opportunities with an expert panel who'll be sharing their insight on how the market is evolving and what comes next. We've got an hour together, and we want to make this as interactive as possible. There'll be time for your questions throughout the session, so please do not hesitate to use the Q&A box to submit them. I think that's somewhere on the bottom of your screen, whether that's during the presentations or as any issues pop into your mind. Please, before we get started with our discussion, I'd like to hear from, and I'm sure you would, who's joining us today. So we'll go round. Please introduce yourself in the chat. Let us know your name, your organization, where you're joining from, and a little bit about your background. We'll start off with first guest, Mary Ann Clark.
Hi, Colin. Can you hear me okay?
Yeah, absolutely.
Hi, everybody. My name is Mary Ann Clark. I'm the Director of Data Center Delivery across Europe for Aecom. We are a consultancy firm who look after our clients, looking at site due diligences, detailed design, construction administration. We're also heavily involved in sort of energy, front stage. And I'm very excited to be here to talk to you about some of the interesting topics there are in the data center sector.
Fantastic. Thank you very much. Nice to have you with us, Mary. And the second guest is Brian Moorhead. Brian.
Thanks for the intro, Colin. So Brian Moorhead, Grid Services Director with eSmart Networks, and also represent our IDNO business, Advanced Electricity Networks. So I'm a chartered electrical engineer by trade, I suppose. I've spent my whole career in transmission and distribution connections, so not just getting data centers connected to the grid, but covering all sorts of different developments, whether it's large-scale power stations, battery storage, manufacturing, and everything else. But obviously a particular interest in data centers given their specific power needs. And yeah, as a business, we do sort of full end-to-end all things grid in specifically the UK. So we work with a lot of the end user hyperscalers doing a lot of their power due diligence or assistance in development early stage. We work in the edge data center space with developers and operators there, and then everything in between in terms of the large developer owner operators and everything in between as well. So right from the early stages right through then to design, build, and then actually asset ownership as an independent DNO of electrical grid connections in the UK.
Very important part of the process. Over to our final guest for today, last but not least, Oliver Titley.
Hi there, I'm Oliver Titley. I'm work for Pure Data Centers. We're a developer for hyperscalers doing large data centers. My background is 15 years in the industry, so I've seen quite a lot of the growth of the market and where it's taken us, starting in D&B and consultancy and moving to the developer world. So I've got quite a good holistic view of how and where the industry's been and where it's going, which is a front row seat in the Wild West is what's been happening. It's been very interesting and an enjoyable ride so far.
Yeah, that's why we're here, to find out where we've been and where we're going. So maybe I'll start with you, Oliver. I think possibly before I educated myself, and part of my education is today obviously hearing from some experts, I maybe thought of data sheds as just being sheds with servers in them, and it being a fairly monolithic sector, but that's far from the case, isn't it?
Yeah, exactly. It's probably the most common misconception as we read about data centers in the news. There are many different data centers doing many different things, right from the ones in the bottom of a financial house in London that run their own in-house enterprise cloud doing financial services, to large facilities in the middle of nowhere doing huge AI training. Each one has its own challenges, customers, size, market conditions. Some are concerned with latency, some are concerned with just how much power they can get, some are concerned with never being offline, so they have very high resilience requirements. And understanding that is the key. Somebody used an analogy, they're like factories, in the sense that a steel factory is completely different to a factory that makes bottles. That the way you set them up, the way you build them, who the end user is totally different. And understanding that market is critical before entering it.
Yeah, that's interesting. So each of those different sub-segments, if you like, would have different design and construction challenges. I mean, maybe Marianne, you could pick up on that. You're presumably working with people across the spectrum, are you?
Yeah, so we're obviously multidisciplinary. A part of the clients that come to us, we do work with hyperscalers and co-locators. We had a discussion earlier about whether co-location is the right terminology for the clients these days. But yeah, we, as part of the build, there is a lot of work that goes into the design. They are very fast-paced projects from a design point of view. Looking at sort of the groundwork, you've got all the civil structures and architecture work that needs to be done, and then the MEP part of the build is quite complex. The coordination between the different disciplines gets quite technical. And as a business, we've sort of been driving to look at how we can make efficiencies in the way that we deliver the projects. So the teams really have to work together. The clients are very demanding. Oliver, I'm sure you're nodding your head there. And so it's really a different way of delivering projects. I've actually, my background was with, I came from the commercial background, and the pace that the difference between a commercial building and a data center, it's just worlds apart. So it's been a really interesting eye-opener for me coming in and seeing how quickly we have to deliver some of these projects.
To give you a kind of a bounce back on the speed to market being king in this world, when I started, we were fast. 15 years ago, we were, somebody wanted a 5 megawatt site and they wanted it, within a year. And at that point of time, the level of cost and capital that you're putting down for these things, you could afford to do a 5 megawatt build speculatively, let it sit there, and when a customer needed it last minute, they could come in. That was kind of the old co-location market. Now customers are like, oh yeah, we want 100 megawatts by the end of next year. And you're like, who does this? Like, you just don't have that equipment and power lying around paid for. And the market hasn't really adjusted to that. So we're in this kind of world where the customers are still IT customers who still think that this is like buying a service when this is now an infrastructure game where, as Brian will attest to, you want 100 megawatts in the middle of London. Ooh, that might be 2032 you're looking at. But you're still in a position where the customers won't move until they've got this 2-year window or less, even a year. So we're in a position of our gamers to try to get everything prepared, power, land, and then wait for the customer with a trigger, and then it's run. So we get the go. We want this in 18 months, and then we have to design, build, deliver, commission massive buildings, massive campuses of buildings in a space of 18 months to 2 years, which is, that's not about messing around with detailed design. That's around how can we move at speed? What can we have prepared already? How can we have done everything in advance and have everything that we've got commoditized, set up, supply chain secured to deal with that, which is the challenge of the market for sure today.
Yeah, we'll come on to dive down more into that in a bit, but I guess maybe it'd be worth taking a bit more of a helicopter view and just talk about that demand issue that you raised there. Obviously, you're talking about the challenges of meeting the demand, and we'll come on to talk about that, but just give us an idea about the market and where we are and how big it is. How big is it likely to get over the next few years, Oliver?
So I've had quite good exposure into a lot of work with hyperscalers for sure, and reading up the news and what's going on. I mean, to give people a kind of a concept, the data center market in the US is overtook the size of the office market in the US in 2015 as a like for like, and will probably seek to overtake where the office market as is now next year. So the size and scale of the what is being deployed is completely unprecedented. I was reading an article this morning even that said the US GDP would have been stagnant had it not have been for for growth in the data center market. It's important to note that the US is leading this boom, and it is a boom there without a doubt. Europe and Middle East is lagging behind, but it is no means not moving. We have two different markets that are in play right now. One is the growth of traditional cloud, and one is the growth of the AI market. The growth of the cloud is exponential. The growth of the AI market is logarithmic. So you've got both of those in play at the same time, which is what's creating this extreme maneuver in the market that we're seeing right now, where what used to be a 10 megawatt ask is becoming a 100 megawatt ask, and what was a 100 megawatt ask is becoming gigawatt asks. And it's eventually supply and demand in the market at the infrastructure scale is pushing back, and now we've got this rock and a hard place is how we continue to serve this growing market with all these challenges. And that's where you see very specialist companies come in to try to solve these problems that we're seeing now, because you can't just buy a massive field, massive load of power and put a data center up. That's where you see guys like Brian and Marianne coming into working with what we've got to make things happen in a constrained market where we still got to try to achieve these things.
Yeah, I'll come on and ask Brian about that in a second. The power issue is really important, but just quick before that, Mary, I mean, from your point of view, what are you seeing in terms of requirements from clients, and then moving on to, sourcing the contractors to be able to do the work? Just summarize where we are at the moment in the market.
Yeah, so as I suppose Oliver touched on there is a variety of routes. What we're seeing is in the design of our projects, we might be in a position where we're actually redesigning the ventilation system and the electrical systems, because I'm not sure there is 100% a surety of which way the sector is going. And so what we're finding, as well as trying to deliver at speed, we're having to pivot. This is the word that I came onto when I moved into the sector. We're having to pivot our designs and the technology, talking about the sort of specialisms, because of the increased power densities, we're having to provide different forms of cooling and cooling for the data center. So I'm sure a lot of you will have heard about liquid cooling as a new sort of technology that we can look in to try and overcome some of these heat gains that obviously the racks within the buildings are creating. So it's, from our point of view, it's about trying to be agile. From a demand issue, obviously power is a massive issue generally, because we don't seem to have enough power for what our clients are asking, and sort of on a permitting side as well. And then obviously land is an issue, because these data centers, or campuses as they now are looking at, can be vast. So I'm sure we're going to get to a point where, can we keep increasing the power density versus the amount of cooling? And a lot of people here are sort of heating and ventilation. Have we got the space for all the plant? Or there is going to be a crunch point, I think, but we're going to have to wait and see on that.
So yeah, let's jump in, because it makes me laugh on what you talked about the planning side. I spoke about how they want speed to market when you get a job, but you don't have requirements at that stage. So you're having to gaze into a crystal ball of technology 2-3 years out, put all your environmental permitting in, all your planning permitting in, and then just when the customers come along, they come along with 100-page requirements, and you're like, yeah, good luck with that. It's just how the world is moving so fast. You have to kind of pick a route, and it's so difficult to do that right now. And that's really the art of what the clever side on the engineering is. It's really hard.
I'm desperate to bring Brian into the conversation, but just as a preliminary before that, what takes longer? Is it the kind of applying and getting approval for the power connection to the grid, or is it the planning process itself in terms of applying for planning permission?
Depends where you
Yeah,
are, what your unique situation is. Like if you're buying a brownfield building that has power, it's a completely different situation from if you're going somewhere new. So it again comes down to that not all data centers are the same, but
Yeah.
generally speaking, on the bigger scale, power leads.
Brian, we can resist no more. It's time for you to come into the conversation and talk about power, because that's obviously something everybody's interested in, and one of the big challenges to getting this stuff. Maybe just to begin with, just give the audience an overview, if they don't know already, what's required and what's needed to be built to build a data center.
Yeah, I'll just start bit high level, I suppose, Colin. So like in UK power terms, there's kind of a rough rule of thumb, if you like. So if you're an edge data center down in sort of the sub 10 megawatts, that's typically going to be on 11 kV networks. That is where your sort of your 1 year type delivery that Oliver was quoting from sort of that would have been maybe the market 10-15 years ago, but there still is development on the edge side of things, albeit most people do want to talk about the kind of the hyperscale and the bigger numbers. Beyond that, I don't know if you'd agree, probably 5-10 years ago then the kind of the cloud market moved towards more the kind of 50 megawatt type level. If you'd agree, Oliver, that tends to be where 33 kV as a voltage level then starts to kind of top out, roughly, very rough. This is very broad brush. And again, that's kind of deliverable within like a 2-year time frame. Again, this is all broad strokes. And that's kind of where the market was, particularly like when the initial kind of big data center boom happened in Dublin, as an example. A lot of them would have been in around that 30, 40, 50 megawatt. And now the market has shifted to that kind of 100 megawatt plus, which throws you into a totally different voltage level, which then subsequently throws you into a totally different game in terms of time scales, in terms of risk of delivery, in terms of size of plant and everything else. So you're up into the 132 kV voltage levels, and sort of the much bigger, more onerous, longer lead infrastructure, and that's where, leading on from Oliver's comment there, that it's now becoming an infrastructure game. That's where that's at. Things like transformers could be on a 2-year plus lead time alone, and there's a lot of design work to do. Each of those transformers is relatively bespoke. If you think about it, you're plugging into a grid that was designed back in the 50s or 60s. Most of it is all kind of designed not really against a common standard back in the day. So wherever you are in the UK, you could be plugging into a grid that was designed slightly differently. So any of your interface kit, a lot of it is bespoke specification to that particular connection, which a lot of customers don't get their head around. They kind of just think, oh, 100 megawatt transformer, sure, let's just put 10 of those on order for these 10 data centers we're going to roll out. Well, actually, no, there's probably 3 to 4 months worth of design work specifying CT specs and XYZ on the, winding ratios and all sorts of things on those specific to that grid connection. So you've just got inherent stuff that you just can't really compress timescale wise there on that. The bigger issue, even though over delivery in the UK at the minute, is actually there's a process driven issue around getting access to grid capacity. Then I was just checking latest stats this morning. So just for context, roughly peak demand on the Great Britain electricity system, it peaks out around 40-45 gigawatts. That's like the peak of winter maximum electrical load on the GB system. I think the minimum's in around 15 to 20. Around the start of this year, the queue for new demand connections, and it's not specifically data centers, but a large portion of, probably the majority is made up of data centers, with accepted connection offers from the network operators, deposits paid, was around 20 gigawatts. As of this, I was looking at the stats this morning, I think as of sort of end of May, June, that's now 106 gigawatts. So if you take peak GB demand at the absolute peak of winters in around 45 gigawatts, there's another 106 gigawatts of accepted connection offers sitting in the queue waiting to connect. And that largely will be a lot of data center developments. Now, the process issue is if you come with a new development tomorrow and you put an application in, you're going to the back of that queue at a nationwide level. And obviously, I think probably a lot of people will be aware of the previous issue a year ago was renewable. The renewable queue was hitting 900 gigawatts, so it was like 5-6 times what we need to meet net zero, just because of speculative development. The grid operators and Ofgem are responding, raising the barrier for those, and they're going to kick a lot of that out of the queue. What that's then driven is a lot of those developers have now just started to try and flip those projects, and all of a sudden there's a field out in the middle of some random place that probably no data center operator would ever go to. Is now being changed into a data center application just to try and keep a project alive to flip at some point in the future, but it's probably never going to get built. So there's a massive amount of speculation on power for data centers at the minute, and the processes and regulations in place don't really prevent it from happening. So that's one of the biggest issues. If for anybody looking at a new project now, that's one of the biggest issues. You getting access to power behind that speculative queue.
And how long does that queue take to get to the front of?
Well, this is it. If people are paying their deposit, based on current rules, they could sit in that queue for years before they're actually kicked out. So again, this is what was happening with large speculative battery storage and solar schemes. Again, because those loopholes are being closed down, and that basically the National Grid Connection Reform process introduced new requirements for things like land right. Again, people are booking up gigawatts of capacity without even having land rights. So again, that's all been tightened up. Evidence submissions had to be made by the end of August, and there's now a process that National Grid are going through to basically kick people out of the queue. Albeit that was supposed to happen sort of by the end of Q1 next year. The timescales in that have all been pushed back then as well, so that's going to run on through the majority of next year now. I think the latest timescales is anybody that's already in the queue for a couple of years and due connection this side of 2030 should kind of have a formal update by the end of, I think, Q2 next year now. But people that are kind of sitting with dates beyond that might not get an update into the second half of next year now, is based on the latest timescales. I'm pretty sure that's it'll be on NESO's website if you just Google it, but that was just recently updated there last week.
Interesting. Yeah.
I would say I am expecting some regulatory change around this to close the loopholes on the speculative data center side of things. So I think it is a bit of a watch this space that definitely will get tightened in on.
So those regulations could kind of restrict speculative development?
Yeah, be tighter on things like, does this project actually have land rights? What's the plan status of it? Things like that to kind of restrict speculative sort of capacity hoarding and things like that. And to touch on Oliver's point about all the different subsectors, that's one of the, we get requests weekly. Can you get me 100 megawatts for a new data center? And the first question is always, right, well, what type of data center is it you want to need, or is it you want, because that massively influences the specification of your power connection. We hear lots of myths and rumors about, oh, well, we need diverse cable routes, we need this, that, or the other. Well, it actually depends on what type of data center you're building to what those requirements are in the power connection. And you can't leave it up to the network operator. You can't just put in an application for 100 megawatts and let the network operator decide all this stuff for you, because you'll get badly caught out down the line. So again, we would do a lot of the design on behalf of the network operator at that application stage, based on that specific data center application. Before you go any further. Whereas a common mistake we find all the time is somebody's got, just because they've went and got a connection offer from a network operator, that's not worth the paper it's written on. If it's not been designed correctly, if it's not been thought through, if it's not a full due diligence. The network operators, they're processing hundreds of applications a week. They've probably spent all of 5 to 10 minutes looking at it and drawn a line on a map type thing. So they're typically riddled with major cost and timescale risks.
So that's the process for grid connections. In terms of the planning application process, how do you time that if you're a developer or a client? How do you time the process, given that that process for grid connection can take a long time. Are you having to draw up designs earlier in the process to get the grid connection prioritization, or does it take the pressure off because you've got more time to prepare the planning application, Mary?
So you're always looking for your clients to try and drive that program down as much as possible. So and depending again on the location, you have to have a design that is in a position that could be put forward and that is possible to build. So there are various REBA stages that we go through, and obviously once we get to the right point, we can then issue for permitting. Then the design can still continue working in parallel. It obviously depends on how keen the client is to get to that point. But we are, I would say, is it a vicious circle, or are we fueling our own benefits? But obviously the clients need the data centers, the designs need to be done as quickly as possible, and the power needs to be secured. Because if you're not in a position ready to take the power, then you're going to be passed over, as Brian said. So we're in this circle of speed and demand that obviously Oliver and I were sort of touching on earlier. So yes, the earlier that we can get the designs in, and we're finding that clients are actually bringing contractors in at an earlier stage now, because they're looking at how they can get to that point of building as well. So we are working with contractors as well, so that we can try and help with the designs that we understand, and trying to look for sort of standardization so that we can deliver quicker. And then obviously, and we haven't touched on it yet, modular buildings as well is another way of trying to, well, you've got your safety aspects, but also that speed of process. So there are a number of manufacturers out there at the moment looking at how they can deliver data centers in a modular way that are almost plug and play. But that's another side of the design process.
That's interesting. So early contractor involvement is something most
sort of
contractors
stage 2.
love.
So,
right.
some contractors are coming at stage 2, working with clients. So because obviously buildability is key. Traditionally, you would go through the REBA stages and then you go to tender, but we're finding sort of a 2-stage D&B kind of contractors coming in for those that are trying to get those buildings done.
And would that extend down the supply chain to M&E contractors, for instance, or is it mainly the main contractors who are then dealing with their supply chain?
It's obviously the main contractors, but they will pull in will pull in their subbies as they go. Yeah,
fine. We've talked a bit about brownfield. It was quite interesting what we were saying about kind of getting connections onto the grid. Is there an advantage to a brownfield site, Oliver, if you're a client in any of the subsectors that you're talking about?
Planning is unique to the region it's being planned in, not just the country. So if you're in Slough, for example, there's a special planning zone where you can basically not, if you're a data center and you meet some guidelines, you don't really need to even go in for planning. So it's very unique to the site, and brownfields can work to that advantage in that you could just level a site and build new up with an existing connection much quicker than you could get a connection in the future, like going back to what Brian's issues were. So sometimes that becomes a very useful way of doing it, but it's not without its own unique risks and challenges. I mean, typically for us, if we can get a brownfield, level the thing and build a new one, it's the best option. Trying to fit a new data center into an existing building is a recipe for disaster, which we would try to avoid.
Okay.
But do you not think, sorry, can I ask Oliver a question? Do you
on.
not think, from a sustainability point of view, we do need to start looking at how we can build more sustainably? And if we look at existing buildings and retro, okay, I'm not necessarily saying obviously we use the buildings that are there, but we should be looking at how we can be more sustainable. And there are data centers, and you've said yourself, you've been in the sector quite a long time. How are we making sure that those data centers, which are almost redundant now, how are we reusing those so that we are trying to be more sustainable?
So this is a very poignant question, and it's
Sorry.
yeah, it's one that investors ask a lot actually as well, because they're interested in this side. There's two parts to this. One is that existing data centers that are there normally have some kind of tenant in them that's totally using it. Very rarely, I mean, I was talking to a hyperscaler, which I won't mention, and they said to me they haven't actually ever moved out of a data center because they've grown so much. Even their existing legacy stuff is still running existing legacy stuff. So it's not like these are old data centers just sat there doing nothing that need repurposing. They're filling a need that was legacy tech and it can be refreshed. So you come along with a new 10 megawatt build demand, there isn't just 10 megawatts of existing supply that needs to get repurposed. So it's not a problem now. Whether it is or not in the future is a different question. The other challenge comes in what the tech is demanding from the infrastructure now. So we're talking about racks, which are kind of the unit of measurement of IT, if you like, in our world, of about 2 tons. So you kind of like, you walk in these things around a facility, the floor slab loading is a problem. What can you do in terms of an old building that doesn't have that level of structural support? You can't just go and reinforce it. So when you combine the fact that there aren't old data centers you're repurposing, basically buildings that were never designed to be data centers, you combine that with the fact that you've got very specific requirements in structural loading, and you need speed to market being your key. And if anyone's ever worked on a brownfield site, speed to market is the death of it. It's so hard to work around what's there and how it works. You know, pulling out a 1980s as-built drawing that's done by hand, it's completely different game. So
Yeah,
fortunately, it's not something we've really had to deal with yet, but it will.
No, it might. Yeah, I think it will. I think it's coming. But yeah, no, I think it's an interesting conversation. Sorry, Colin. Thank you.
No, no, at all. Thank you. It's a really fascinating discussion. In terms of just carrying that one on, as far as I understand it, I mean, you're the experts, but some clients need their data centers. They need low latency. So the further you are away, the longer the internet connection takes to get the message down the wire, to put it crudely. Is that a driver as well? And we haven't really talked about internet connection. How does that influence the kind of selection of site, I guess, is the question. I don't know if Oliver wants to go.
From my point of view, it's a very big driver. It defines where the networking hubs go, and the networking hubs define where their peripheral go. Now, that's particularly true for cloud. AI machine learning that is training a model doesn't care, is a short answer. So it's less dependent on that. It cares about itself internally, but the connection back to the node that's feeding the global grid is less dependent. If you're talking about cloud as a market, it's super important. And how AI inference gets into cloud in the future will also start to play a game. Whether AI remains something that sits on the outside of a town or has to get incorporated into cloud, we'll see. I have my own personal views on it, but there is no market direction just yet as to how that take-up looks and what it's going to do. But yes, if you're looking at cloud, it does matter a lot. And one data center that's within 200 milliseconds latency of another can consider both of them one data center. So I can have 10 megawatts, the equivalent of a 50 megawatt is one site. That matters. Although cost of scale, we'd prefer one big 50 for obvious reasons. But yeah, so it matters if you're talking about availability zones, networking hubs, etc. But that's one application of data centers that's important too. And things like high frequency traders, which used to once upon a time be a big driver of the numbers, but I just don't see much anymore. They used to be very close. The closer the better. And when they were working on the arbitrage sites, to the point where they were almost on the networking nodes, the internet nodes that were in the world. I think it's important to note that the infrastructure that we're dealing with cloud and AI is built off legacy infrastructure. They didn't, in the sense that the telecoms companies in the 80s really defined where they were going. And that's where all the connectivity went. And then cloud kind of went near that because it was just building off of old infrastructure. And a lot of these companies, because people talk to me like, why don't they put data centers in Birmingham or somewhere where it's land's cheaper and there's loads of power? And it's like, because they literally locked themselves in London in the 80s and they can't go anywhere else because it's the huge technical debt that's already based in it. And I think that's important to understand, is people feel like anywhere you get power and connectivity is suddenly a place where you're going to get big data centers. For an application, that might be true, but it is not a general rule.
And what,
So,
if I could
right.
just, what's your view, Oliver, on so like the AI training data centers that don't have as much of a latency requirement?
We
Like
won't see them so much in Europe because we have too much too expensive and too restricted power. You're seeing those move to places in the middle of nowhere in the US or somewhere out in Asia where power, or even the Middle East, where power is so cheap that they can just run it because they don't care where in the world they are. You might see things like Sovereign Cloud doing an AI training center somewhere like in the Scandinavian areas, but that's not global, that's European focus.
I think that is an important point in terms of, because, well, even just as a layman when it comes to the wider data center market, like what, if you can't put it anywhere in the world, why would you put it in the UK where power prices are the most expensive in Europe? Never mind, but I think that sort of puts into context then, all of these 500 megawatt, 1 gigawatt applications that are sitting in the power queue up and down GB in random areas. It's sort of, it'll be interesting just to see how that plays out. I suppose I'm definitely not qualified
to add to that, kind of what might seem a downer in terms of the macro play. There has been a lot of interest because the UK is still a very big tech hub. So having close data centers to the people who are expertise at them, in terms of like Cambridge researchers. I think I was reading an article that said that Cambridge was the top third publishing house for AI in terms of research papers. So we do sometimes put ourselves down that it's in what we offer. And I think that's core to understand, is that there will be AI investment in the UK, more so than the power numbers would suggest. It just won't be where there's a 500 gigawatt campus, because for obvious reasons, we don't have the power. And even if we did, it would be way too expensive. So we will see AI training centers. They just won't be the headline grabbing insane numbers we're seeing in the middle of nowhere in America.
The other thing to touch on as well with location is, I think there's a perception of data centers being bad, because I think there's an educational piece that we need to have with the public, quite frankly, as to what data centers actually are for. We all interact with data centers on a daily basis, and a lot of us aren't even thinking about it. So I think there is a piece, and I was at a panel discussion a couple of weeks ago, and even the government, there is an education there that we need to have as an industry and as a country to make sure people actually understand what data centers are for.
I'm noticing the audience is very engaged, so that's a good sign. You're obviously interesting people and provoking lots of questions. I'm going to go to the Q&A section a bit earlier because of that. There's lots of questions more that I would like to ask, but we could probably be here all afternoon, and it's probably better to go to the experts, the viewers that have joined us today, taken time away from their normal day jobs. I'll try and get through as many as I can. Charlie Jones is asking, is there a trend away from water cooling, or is water cooling relevant to a particular type of data center? We talked about the subsectors there. And who are the leaders in water cooling of data centers in the UK? Who'd like to take that one on?
So I'll just touch on that. There has been a change, obviously, as I mentioned, that power density at the beginning. So when I first came on, I was talking adiabatic cooling. Obviously, that's got water implications. And with the increase in power density, liquid cooling has been certainly a topic of conversation. I'm sure a lot of people here will be aware of it. The manufacturers, I suppose, like Schneider Electric, there are others within the UK. I'm sure if you wanted to do some research, you'd find them quite easily. But a lot of the manufacturers are trying to understand how we can have different systems that can cool quicker and are more efficient because of the increased sort of power density. So yeah, that's definitely the way. But you know, air cooled as well is being used depending on the type of data center.
It's worth also separating the cooling technology from the power density. A lot of people get that confused. They think that because you're high density, you must be liquid cooling. The reality is air cooling can still do a lot more density than we're seeing. But people just assume that, you know, liquid cooling, it's a megawatt rack everywhere, and we'll be doing 2 racks, and that'll be the whole data center. But there's a lot of networking leg equipment that needs to go in that doesn't need this stuff, that supports these high density racks. There's a lot of storage that goes in. So it's an data centers contain themselves an ecosystem of infrastructure where liquid cooling supplies just the GPU rack of high density. And there is still all this other infrastructure that needs air cooling alongside it.
Okay, I'm going to jump with, as soon as I mention the questions, another load piled in. So I think we're going to struggle to get through all 31 that are now sitting there, but we'll try and do another one now. Chris Jelfs is asking, he's addressed it to Oliver, but others might be able to chip in. Are end users looking to procure day one 100 megawatts in the UK? And how do you plan to commission this within an 18 to 24 month period in addition to shell and core? Or do you see a phased procurement approach?
So anybody in the construction world will understand how just insane those numbers are in terms of trying to deliver them at that speed. The short answer is what you ask for and what you get are 2 different things. So the customers absolutely ask for it. Whether they get it or not is a completely different matter. The irony is there's a lot of disconnect even within. People treat customers as an individual who's all knowing. The reality is that the bigger the company is, the more individuals, the more bureaucracy you deal with. And what we typically find is that somebody has a requirement to fill 100 megawatts in 2 years, and yet they've only even populated 10 if they're lucky, even if we've handed it over. So we find there's a lot of back and forth and negotiation and understanding that needs to happen. The key is really the first RFS date that you can get to be ready on service. And then you take a rolling commissioning plan out from there that may not get all 100 megawatts done by that time, but typically it meets the needs that they really need as opposed to what they're asking for. And also,
we're asked to design. Sorry, go on, Amber.
I know the other trick is to use very big pieces of equipment that are repeated so that the teams can roll on. So there is very actually strategy to doing fast commissioning in that time. But yeah, all 100 megawatts is a lot for a very instant commission like that.
Yeah, and what I was going to say from a design side, we get asked to design in parts so that you can leave part of the data center fallow space. So it is thought of so you can effectively build on as the power comes on. So that is part of the sort of the design process as well.
Okay. Anthony Jennings is asking something about, talking about the desire for fast delivery. And I know this is something I mentioned, or somebody mentioned this to me when I was at an event recently, the kind of risk involved for MEP contractors on some of these projects. So Anthony Jennings is asking how developers and contractors balance speed of delivery with the need for, it's jumped up, somebody's put another question on, but essentially resilient systems that were working, effectively, resilient, adaptable MEP systems that remain fully compliant with evolving UK and international codes.
Yeah, so a lot of the design for data centers around resilience, and so we design them with that resilience built in effectively. I think there is always a risk with speed that you don't necessarily get the quality that you need. But as the more we do, we do lots of lessons learned, and if there are issues that we find in projects, we try and share them within the region, and we share them with our clients as well, because as an industry, we're all learning together in a way. So we need to be doing those lessons learned, and improving ourselves and demanding the best. And I think with contractors coming in and prefabrication of different systems, then that can help with safety, with accuracy, and with quality as well. So we will design it, and we hope the contractors will come in and support on those designs and look at how we can deliver quicker, you know, to cost and on time, really, and quality.
Yeah, and Marianne touched on it earlier when she said we're seeing a lot more contractors earlier with designers. That's actually the developer's strategy to try to prove it. So it's not these big chunks between the traditional build cycle, and that the contractor's already on board, already knows what the prices are going to be, and they've prepped themselves so during that design phase. And that's actually one of the strategies that's used to do that with contractors.
Excellent. Okay, I'm just trying to find one for Brian to chip in on. I just saw one in the queue there. It's talking about alternatives to electricity. I know that may be something that you're not keen to promote, Brian, but I mean, in terms of some of this power supply, are there alternatives out there, technologies such as gas reciprocation engines and solid oxide fuel cells using local gas networks as a base load or bridging solution? Do you have any knowledge of those technologies, Brian?
It's probably not one I'm qualified to answer on. I suppose certainly I'll pass maybe over to Oliver to get his, or Marianne as well, actually.
Yeah, I mean,
from my
gas. Sorry, go on. I'll let you finish.
I was just going to say very quick. From my perspective, I suppose that what we hear from our customers is the preference is to get, you know, a safe, secure grid connection. But obviously, there may be time. So there's probably two elements to the question to look at. There's if the grid is time constrained, you know, in terms of it's a few years away, is there a temporary solution to get up and running earlier, or is there an enduring solution that gives you an extra level of capacity? I think it's definitely the strong preference of any client we've spoke to have like a kind of safe, secure, regulated grid connection. But I do know different clients are looking at different solutions there. I don't think I've seen anybody put anything kind of solid into practice up close. But yeah, I'll pass over to Marianne and Oliver there just in case they may have seen some stuff.
But I think the only thing I'd just touch on is obviously in the States they still use gas turbines, which are backup effectively, but I think they've got different regulations in the States. I have heard of people talking about using gas as a backup, but I'm also aware that there are certain clients that won't use it because obviously we're trying to move into a sustainable era, so adding gas in is not necessarily going to be helpful. Occasionally it's used for temporarily, like supporting while the power's coming in. Like just to mention, I'm in Poland at the moment, and I had a really interesting conversation with the guys here. They've got coal here. They're trying to step away from the coal, and they're looking at the small nuclear reactors as a way of powering. We're still a few years off that, but there is quite a lot of conversation within the sector about whether that would be an answer to the power requirements that are needed. I don't know, Oliver, if you've got anything else you wanted to add on that.
You use it when you have to, for obvious reasons. Not everywhere has the availability to be able to even use it in the first place because you need a very large gas supply for a very large site near where you are. We actually have a site in Dublin where we have got permanent gas generation for a site. And we, from a sustainability point of view, use biomethane. We're trying to, when we get the customer signed up, and there's a lot of pieces in play, use biomethane as the drop-in replacement for it. So there are sustainable ways to manage it. The challenge comes in the regulation side. It's that's the killer. So if you obviously now are dealing with a lot of unknowns. A lot of people aren't used to doing 100 megawatt gas powered power stations next to a data center. So there's a huge amount of design, complexity, risk, capital, and then associated legislative environment that can change very fast. So it's just deemed very high risk, but it's not impossible, and you can bridge the challenges of it. But because it's so high risk, it's not one that you would just entertain for no reason. There would need to be a very big demand that's certain in a certain region, in a market that's captured, or you were a hyperscaler and you knew exactly, and you were self-building yourself and you knew exactly what you were doing where you were, then you might consider it in Europe. The rules in the US are different, obviously, because they've got so much gas left over from fracking and where they are, etc. But it really is a case-by-case basis. It's not an immediate solution by any means.
Okay. Again, I want to dive down into that, but I'm going to resist the temptation so I can ask another question. There's a couple of questions about fire risk here and how you deal with that in terms of construction solutions. I don't know how high you would rate the risk, but Dan Gallagher's asking, do you see DFMA precast solutions as a naturally advantageous method of construction for data centers due to fire resistant quality and speed of construction? And I guess that links back to what we haven't really explored as much as I would have liked to, which is the kind of the prefabricated model that Mary-Ann Clark was talking about earlier. I guess the question is, what construction materials are best to use for these projects, and also, as with fire risk being a factor there. I don't know if Mary, you want to go first on that one.
Yeah. I suppose I can touch on it sort of at a high level. Obviously, whenever any design is done, we have a fire strategy. There are regulations, and they differ across Europe. We're obviously talking UK and I here, but that is part of the design that we need to do. We do work with the contractors on sort of the details, depending on how far, they tend to be CDP items, sort of the sprinkler side of things. But obviously, everything needs to be designed to regulation, just like any other building. So I'm not sure whether there's any additional risks. Obviously, there's a lot of power, but assuming it's all installed correctly, it shouldn't be any more risk than any other building. I don't know if anyone else has got anything to add to that.
I suppose on the main power coming in and the main substation, while the data center industry is moving into that level of power and higher voltages, those voltages and those types of power stations have been about since the 40s and 50s. It's not necessarily new technology or anything else. There's strong British standards. There's different ENA and various other regulations around it. So that's a fairly well-worn path in terms of standards around fire risk and transformer safety and everything else. So it's not, as a power engineer, that bit's nothing really new, I suppose. But certainly once it goes inside the building or whatever, that's outside of my remit, I suppose.
Fine. Now, yes, we managed to get through some of the questions, but not all of them. So I'm going to see if there's a way that we can maybe get some post-event responses to some of the questions here. But I'll talk to my team about that. We're coming near to the end now, but I think probably the best way to round off, it's been a fascinating whistle-stop tour through some of this stuff, and hopefully we'll be able to run similar events that are a bit more in depth in future to dig down into some of the weeds of this. But let's go around first of all, and just if you want to give us a kind of view of what the future looks like, where we are going? I mean, there are various talks about an AI bubble bursting at some stage in the last couple of days in the news. Where is this market going? I mean, obviously demand's not going to go away for some time. There may be some readjustments in the market, but just give us a little crystal ball gazing. We'll start off with you, Brian, this time as you're on the screen.
I suppose I'll talk specifically on the power side and the kind of capacity piece I mentioned earlier. Obviously, there's a massive amount of speculation on power for data centers at the minute with projects that probably will never take off. So from a power and regulation perspective, I'm expecting regulation to change, to tighten up on that a bit. Even if you put that queue down to a tenth, that's still probably more data centers than the whole UK industry could build in the next few years, and to keep everybody here pretty busy or pretty flat out. So I think the sooner that tightens up and we get down into real projects that people can get on the ground and get shovels in the ground, that probably the better for all involved. Yeah, that would be my kind of outlook on the grid and regulatory. I'm expecting the regulatory framework to change a bit on that side of things, which I think will benefit everybody.
Yeah, sounds like it. Oliver?
I think each part of the data center has its own crystal ball gazing that needs to be done. So it's hard to just say one thing that's going to be the future of either. You have to try and weigh all the directions from the technological to the regulatory to the customer, and put them all together, which is very challenging to say the least right now, and it takes a lot of thought power from us. So I mean, in our view, I just see different people focusing on different parts of the market and doing the bit that they're doing well. You can't be all things to all people. And as we've discussed, data centers are becoming a massive sector with their own subsector. So you're seeing specialisms evolve and people working on those bits. But yeah, it's still going strong. We haven't got the bubble that the US has, in my view. We still have yet to catch up with that. But there's going to be substantial work, even if it doesn't all come to fruition.
And Marianne, where do you see the demand from clients and then the supply from? We didn't really talk about skills here, unfortunately.
I know. I mean, just touching on skills, we do have a skill shortage. The future does need to look at how we can bring in skills, how we can encourage the younger generations come in, how we can upskill people from other industries. This is a growing industry, and there are other industries that are getting smaller, and skills are so transferable. So we need to be prepared to bring in those experiences, grow as a sector, learn from each other. Try not to beat each other over the heads too much, because we're all trying to get to that end goal and deliver. And it's a really exciting sector. And yeah, we just need to try and get to the point where we're delivering at speed, but we're sort of responsible and sustainably growing as well. So that's what I see for the future.
Well, that's an absolutely fantastic point to finish on, I think, a positive message for the future. One of the most important sectors at the moment in construction. Thank you to all of our panel for joining us today and giving their insights. And thank you as viewers and attendees for coming and viewing this important topic. Hopefully there's more to come from us on this in the future. Thanks for joining us.
Thank you.
Thank you.
Thanks.